So we talked about what is current and what is potential difference in the previous lecture. We also had a basic discussion on what is a resistor and what property it has by which it opposes the flow of current. So let us do simple questions based on the definition of current and the potential difference to understand them thoroughly. So first, let's say that a charge of 20 coulomb flows through a conductor in 5 seconds. Find the current flowing through the conductor. So here, in order to do this, first we will see what all things are present in the question. A charge of 20 coulomb, that means Q is given to us, that is 20 coulomb, flows through a conductor in 5 seconds, that is T is equal to 5 seconds, it's given to us. We have to find the current that is flowing through the conductor. So how can I relate these three parameters here? Of course, we have this definition of current and we can relate that using I equals Q by T. So if we put the values, we get I as 20 by 5 amperes, because SI unit of current is amperes. So we get 4 amperes as the final value of the current observed in the circuit. Okay, this is very clear, very simple question. Another question we will do that involves the usage of second definition, that is the potential difference. Let us say 20 joules of work is done to move a charge of 2 coulomb from one point to another. We have to find the potential difference, right? PD is the potential difference. So everyone will pause the video and try to solve this question and match the answers later on. So what we have been given here, the work of 20 joule is done and the charge which is moved is of 2 coulomb magnitude. We have to find potential difference, that is V. So how we can relate them? Exactly by using the second definition which involved potential difference that we saw. So V is equal to W by Q. If we put the values, we get V is equal to 20 by 2 and the unit of potential difference is voltage or volt in short, written by V. So answer will be 10 volt, right? This simple. This question is also very simple. Okay. The third question that we will do, it involves the usage of both these expressions that we learned. Let us suppose if 20 coulomb of charge which was flowing through a conductor,
Sir?
current observed was 2 ampere. Find out the time for which the charge was flowing. So here also what do we see? What all things are given here? Charge 20 coulomb is mentioned to us. We have to find the time. And what's the current given? Current is 2 ampere. So how we will relate them? Using I equals Q by T. So we will put the values, we'll get 20 by T and that will give us the value of T as 10 seconds. So this 10 second is the answer.
Sir?
Okay. The next question. Let's say a current of 2 ampere was observed in a circuit for 2 seconds. We have to find the potential difference applied across the conductor if 2 joules of work is done. 2 joules of work was done.
Sir,
So here we need to look carefully what is given. You
sir,
all can pause the video, try to get the answer and then match up with the solution that we have here. A current of 2 ampere, let us write down what we have, is observed in a circuit for 2 seconds. So time is 2 seconds. We have to find the potential difference, that is V, applied across the conductor if 2 joules of work is done. How much work is done? 2 joules.
sir,
So if you look the expression of potential difference, it is work by charge. So we have with us the value of work which we can put here,
sir,
but we need to figure out the value of the charge which we can get using I and T, because we know I is equal to Q by T. From here we can get Q as I into T, and that gives us the value of Q as 2 times 2 coulomb, that is 4 coulomb. So we will put this value 4 coulomb here and we'll get the potential difference V as 2 by 4, that is 1 by 2, and the unit will be volt. So we have found out
sir,
the potential difference. Okay. So let's meet in the
sir.
next lecture, because this was just a practice session based on what we have seen in the previous lecture. So we'll talk about resistance a little bit in detail and the factors on which the resistance depends. Okay, see you. Bye bye.